In this video we are going to discuss the dot product, where you take two vectors and multiply them. It's called a dot product because it's usually denoted by a dot, this multiplication, and as the result you get a scalar or a number. That's why it's sometimes called a scalar product, because the result is a scalar, a number. So the way it works, you have two vectors, a and b, and their dot product is the length of a multiplied by the length of b and the cosine of the angle between the two vectors. So imagine these two vectors shifted so that they have the same initial point and they make some angle theta, and that's the theta that enters this formula for the dot product. Okay, so this is a very handy tool, the dot product, which basically measures how much the two vectors point in the same direction, and it's because of this cosine factor. As it measures it takes the cosine of the angle between the two vectors. The cosine of 0 is, as you know, 1, and the cosine of, so that's when they point in the same direction. So that's when the product is simply the product of the length. And if the angle is 180 degrees of pi radians, then the two vectors point in the opposite direction, and the cosine of pi is -1, so then you get the product of lengths multiplied by -1, so that's a negative number when the two vectors point in opposite directions. And also there is the special case when the two vectors are perpendicular to each other, when the angle between them is 90 degrees, theta is pi over 2, then their dot product gives you 0 because the cosine of pi over 2 radians is 0. So no matter the length of the two vectors. Okay, so that's the basics of the dot product. Now, if you have the vectors given in, now let's just look at a question. So question 1 that I would like you to answer is, what if my two vectors a and b has length 4 and 6 respectively, and the angle between them is pi over 3 radians, so that's 60 degrees. So what's the dot product? Pause the video and input your answer in the box below. I hope you paused it. It's a simple calculation where you just apply that formula. So you take the length of A times the length of B times the cosine of the angle between them. Well, you might remember that for pi over 3, 60 degrees, the cosine takes the value 1 over 2, so half. So that's just 24 divided by 2, that's 12, okay, for the dot product. So once you have the components of vectors, and that's going to be a second formula for the dot product, if the vector A has the components A1, A2 and A3 for the x, y and z components, and vector B has the components B1, B2 and B3, then the dot product of the two vectors can be calculated or computed using the components in the following way. You take the products of the first two components, add to that the product of the second two components, and add to that the product of the third two components. And so this way you again obtain the dot product of the two vectors. And in fact, if you have the length, you have the components of the vectors, you can compute their length, you can compute the dot product via that formula, and that way you can actually obtain the angle between the two vectors. Now before doing that, let me just give you a quick question. So what if my two vectors are 2, 4, 0 and 1, minus 3, 0. So you see that the third components are in fact 0. So these vectors lie in the xy plane or are parallel to the xy plane. So what's the dot product then? So what's A dot B? Pause the video and input your answer below. Okay, I hope you paused it. All we have to do is just take the first components, multiply them. So 2 times 3, add to that the product of the second components, 4 times minus 1, and add to that the product of the third components, that's 0 times 0. So I get 6 minus 4, which is 2 for the dot product. Okay, I hope you got that right. And as I mentioned, using these two formulas, you can actually compute the cosine of the angle between the two vectors, and that's just taking the dot product. So if you have the components of A and B, you can compute this dot product via this formula and divide that by the product of the length of A and B to get the cosine of theta, and then using your calculator you can actually compute get the length, get the angle between the two vectors. Now for the third question, I would like you to answer explain why the vectors given in terms of the basis vectors 2i, 2j minus k and 5i minus 4j plus 2k. So my question is, and your task is to explain why these two vectors are perpendicular to each other. Pause the video and explain why they are perpendicular below. Okay, I hope you paused it. Well, the reason they are perpendicular is, like I said, that the reason that the angle between them is pi over 2 is that this dot product is 0. These are non-zero vectors, so if the dot product is 0, it has to be the cosine of theta factor that vanishes, so it has to be theta equals pi over 2 in that case. So if I now compute the dot product, let me call these vectors A and B. So if I now compute the dot product of these non-zero vectors, if I get 0, these are perpendicular vectors. And in fact, 2 times 5 is the product of the first components. Then I have to take 2 times minus 4 as the product of the second component. Finally, I add to that the product of the third components. That's minus 1 plus times 2. So I get 10 minus 8 minus 2, which is 0. Which exactly tells me that these two vectors are perpendicular. Okay, I hope you enjoyed this video and I'll see you in the next one.